Alright, so most of you have used ipconfig or ifconfig on Windows, Unix, Linux, Mac, and you see your IP address, subnet mask, default gateway, and you just go, yep, there's some numbers, good to go. Well, we're going to refresh our memories of some of this information about the IP addresses and, more importantly, subnet masking. So shall we? Let's move on. So there's two types of IP addresses. You have a public and a private. That's the only two types that exist. There is some conjecture about the APIPA or loopback, but they actually fall under a private IP address. There's only two. We're only going to be talking about IP version 4 here. Let's figure out version 4 before we dive into IP version 6, because you want to blow your brains out after watching or reading about that. So every IP address is broken down into a class. And they are simply Class A, Class B, Class C, D, and E. In this tutorial, we're only going to focus on A, B, and C. D and E don't really apply to what we're going to be talking about. So the first octet of your IP address is going to define which class it actually falls into. And that is as follows. A Class A starts from 0 all the way through 127, Class B 128 through 191, and Class C 192 through 223. 224 throughout the rest of the IP range is all the Class D and E that we're not going to talk about. So the IANA, very cool company by the way, you could run out of a notebook, defined out of these entire IP ranges which ones could be actually used for private use. So your numbers range wildly. But these private use numbers, which are in your own home or business, cannot be used on the public internet. This is a rule that cannot be broken. They cannot be seen on the internet, period. And they are as follows. A Class A is 10.anything.anything.anything. It is private, automatically has to be, non-negotiable. Class B, 172.16 through 31.anything.anything, has to be private. Class C, 192.168.anything.anything. That's one of my pet peeves that everyone thinks. As soon as I see a 192, oh, it's automatically private. No, it must be 192.168. Then it's a private. 192.167 would be a public. If I actually use these classfully, it actually will tell me how many devices, machines, PCs, phones, tablets I can actually have in that network. And those numbers are, for Class A, 16.7 million and some change, but what's a couple 100,000 between friends? Class B, a total of 65,534, or Class C, just a mere 254. Well, how do I come up with these crazy numbers? Math, hello. So, if we remember how IP addresses are written, they are written in decimal format separated by periods. So number, and those numbers range from 0 to 255, dot 0 to 255, dot 0 to 255, dot 0 to 255. Now, that first number has already been defined for us, and there's three variables left over, and they are 0 to 255, 0 to 255, 0 to 255, sold. If we actually take those total numbers, 0 to 255 is a total of 256. Since there's 256 possibilities in each one of those slots, all we have to do is simply multiply them. All I have to do is 256 times 256 times 256, or 256 to the third if you're into the whole exponent thing. 256 times 256, or just simply 256. So the first one's going to come out to around 16.7 million. 256 times 256 is 65,536, and 256 is 256. Now I'm going to roll back up to these numbers. There they are. Hold on. Didn't you say 65, 536, and 256? Yes, I did. However, we're going to be subtracting 2 from that last number, and we'll talk about that towards the end. So, now that you can actually see the total amount of IP addresses you can have in a network, yeah, most people are rocking a Class C, because you don't have 16.7 million devices in your house, let alone probably even 20. So we're going to stick with Class Cs in most environments. The next number you see after the IP address is the subnet mask. One of my favorite things to talk about. This is something that can definitely woo the opposite sex at the bar. So, real panty dropper. You've probably asked through your career or just minglings, what is it? What does it mean? What does it do? And you probably got some answers like, don't worry about that. It's too complex. Or my personal favorite, as long as it's a bunch of 255s and a 0, you're cool. Into that I say, no, bad, can't. No, no, no. Subnet mask actually does something very important. It's going to define your IP address. If you think about your IP address as an identifier, you have a first name and a last name. Your first name is a identifier for you. Your last name is an identifier for your family. So in this case, host would be your first name, network would be your last name. One of the popular misconceptions is we just slice this thing right down the center and say that the left side is the network and the right side is the host. No, 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 once again. The subnet mask is going to tell me what numbers are what. That's what it's there to do. So let's look at one example. And we have an IP address of 172.16.200.2 with a subnet of 255.255.0.0. Now I want you to notice that I've lined up the IP address directly above the subnet mask, even though I've actually added some spaces. I did that for a reason. So I'm going to look at this IP address here once again. 172.16 is the network and 200.2 is the host. Notice the brackets. In this example, 10.158.43.8 with a subnet of 255.0.0.0, 10 is the network identifier. Notice the brackets. And the last example, I have 192.168.55.52 with a subnet of 255.255.255.0. 192.168.55 is the network identifier. Note the brackets. Now look at all three of them. Common factor. Look where the subnet is in relation to the net ID or network identifying portion of the IP address. Do you see it? You should. It's blue. Look, it's right there. It's blue. Very good. So here's a rule for you guys. 2 devices, 3 devices, devices in general have to be in the same network ID to communicate each other, as long as they are not connected without a router. So in a switching network on an island with you and a generator and a switch, they have to be in the same network ID range. So these 2 machines here, the one on the left has a 172.16.31.14 with a subnet of 255.255.0.0. And the right side machine, 172.16.232.69 with a 255.255.0.0. These machines actually can communicate with each other because they're in the same network. Note, there is no brackets, but 172.16 is the network identifier on both machines. Although their host IDs wildly vary between 31.14 and 232.69, they can still talk to each other. These 2 machines here cannot. Look at their net IDs. 172.16 identified by the 255.255.0.0, and we have 172.151 identified by the same subnet. Those net IDs do not match. Those machines will not talk to each other. But they start with a 172. No, the net ID does not match. Just because the first number matches does not mean they can talk. So let's do a little quiz here. Will these 2 machines talk here? 10.3.2.1 with that subnet. 10.90.24.43 with that subnet. Will they talk? Survey said, yes they will. These 2 machines here, 172.16.32.223, talking to 172.15.32.224. Again, look at the net ID. What do you think? Yeah, no, they are not going to talk to each other. I'll flip back real quick just to look. 172.16 is the net ID on the left. 172.15 is the net ID on the right. The net IDs do not match. They do not talk to each other. Now these 2 little guys, 192.168.200.223 and 192.253.8.91. Will they talk? Now most of you are looking at this IP address going, wait a minute, you usually see a 192 with a whole bunch of 255s, but doesn't matter. Will they talk based on what I've told you? Yes, they will. Well, someone will ask me, did I just break some rules? Just bend them a little. So to understand this, we've got to go back to our classes of IP addresses, prepare for flight across the awesomeness of this canvas. Class A, when used classfully, will have a subnet of 255.0.0.0. A Class B would have 255.255.0.0, and a Class C 255.255.255.0. But guess what? I can mix and match IPs and subnets. I don't always have to use them classfully, especially in a home network or a business LAN. As long as it's not on the internet, I can actually bend and break some of these rules. Well, I've seen one way to note IP addresses and subnet. Let's look at one more way. So we have 192.168.1.3/24. Note that the subnet mask is not there as I usually put it there. The /24 is actually the subnet. This is known as CIDR notation. And that CIDR, for those of you who love acronyms, that is classless inter-domain routing. Once again, will definitely woo the ladies at your local. So a 255.255.0.0 is a /24, 255.255.0.0 is a /16, and 255.0.0.0 is a /8. It's a shorthand, nothing more. So that /24 indicates to me that the subnet is, in fact, 255.255.255.0, and we'll get to that towards the end of the slide, or whatever the hell this is. So, some different subnets. These are not the classful ones. These will be classless or custom subnets. So I see a /30, a /29, a /28, and they are different numbers. So IP addresses are changing and the subnets are changing. But before we actually dive into these little custom subnets, we have to know something. Every network has three distinct types of IP addresses, and they are the network, the routable, and the broadcast. So the first IP in the network is called the network IP address. It's simply just a placeholder. Think of it as a bookend. It says, I am here, I'm the starting point. It's not used, it's not given to a device. It's just there as a placeholder. Anything in the middle is a routable IP address. This goes to your PCs, this goes to your phones, your tablets. Anything that gets on DOS interwebs will have a routable. And the last IP address is called the broadcast. It's going to send any traffic you address to that to every single device in the network. Well, why that would be useful is instead of telling 250 different machines the same piece of information, it's a lot of data to send, we'll actually send it to the broadcast. They'll go and make a copy of it and send it to every single thing in the network. So it's very useful for different applications. But we're not going to talk about it here. Let's go back to those IPs. So in this 173.2.462.12/30, which you'll see the /30 note annotation for it, 255.255.255.252. So in that /30, it's a very small network. It only has 4 IP addresses. It has .12, 13, 14, and 15. So .12 and .15 are the network and broadcast, and 13 and 14 are your routables. In this IP address here, 173.2.462.8/29, notice the subnet 255.255.255.248 is equivalent to that /29. And that IP address and subnet breakdown gives me a total of 8 addresses for the entire network. And they are as follows: 8 through 15, the first one being the network, last being the broadcast, and anything in the middle being a routable or usable IP address. And the last one I'm just showing off, and we could do this all day, is the /28 gives me a subnet of 255.255.255.240, a total of 16 IP addresses, and I'm just not going to write all those out because that's just a pain in the... Alright, well, most of you are probably wanting to slam your head into the monitor right about now, and none of it's making sense, because we truly didn't explain what a subnet is. So let's do that. So, subnet mask. If you were to break this word down, sub meaning below or really crappy hokey. Net meaning a network. Mask. What does a mask do? It hides, it conceals, it covers. Well, it's exactly what we're doing here. So if I look at this IP address, and we'll use this as the example, it's a very common one, typically assigned to your Netgear router, Linksys, Cisco router, whatever it is, and that default Class C subnet. Well, you're going to use this as the example. So we kept referring to these numbers as an octet. What the hell is an octet? Referring to powers of 8 or in 8s, nothing else. This is always going back to a concept of that mask. It's hiding something. The witchcraft that you don't want to look at, and that happens to be binary. The zeros and ones in which this machine operates. That's all it understands. It doesn't understand a 255. It doesn't understand a 192. It only understands ones and zeros. So we have to go through some quick binary math. Stay with me, get a drink, and then pause it, come back. Zoloft might help. So normally in your head, 1 plus 1 equals 2, and normally you're right. But in the binary world, 1 plus 1 equals 1, 0. It's never said as 10. It's 1, 0. But it is equivalent to 2 in your head. Probably scratching yourself right now. So you only can use ones and zeros. However, we need some type of grid. So think of this like a map legend. in a right-to-left format, if I were to place numbers in here, and the only numbers I can place in those blank slots are ones or zeros. A 0 does not count the value above it. A 1 will. So if I wanted to write the number 0 in this grid, it would be 0, 0, 0, 0, 0, 0. If I wanted to write the number 1, it would be 0, 0, 0, 0, 0, 1. If I wanted to write 5, 0, 0, 0, 1, 0, 1. I need to use the placeholders to represent the value above it. So using that grid, number 7, here's the example. Just look at it, makes sense. So I don't need 32 to make 7. I don't need 16 to make 7. I don't need 8 to make 7. But I do need 4. What do I have left over? I need 3 more. Well, I need a 2, that gives me 6. I need a 1, that will give me 7. Another example, if I want to make the number 22. So I don't need 32. I do need 16. I don't need 8. I do need 4, I do need 2, and I don't need 0. So 0, 1, 0, 1, 1, 0. It comes out to 22. So get back to all this octet craziness. Back over here. So that same grid again, we're just going to knock it out to 8, because that's what we're dealing with is octets or powers of 8. So I have 8 grids now. And again, reading from right to left. Notice that they double, because that's just how binary works. 1, 2, 4, 8, 16, 32, 64, 128. So this is 8-bit system. Using the 8-bit system, the value that'll be derived maximum from an 8-bit system is going to be 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. Well, since they're all even and only one odd, the number must be odd. And if you're pretty smuck and fart, you figured out that that number is going to be 255. And here is your subnet mask in its binary format. This is what the subnet mask is. It's masking what you don't want to see. All that craziness of ones and zeros. I don't want to look at that, but it is there. So it is all those ones and then those couple zeros at the end for that subnet mask. So here's a rule for you. Subnet masks have to be continuous blocks of 1 and then zeros after it. And you cannot have 1, 1, 1, 1, 1, 1, 1, and then 0, and then another 1. It's got to be straight 1s and then straight zeros. That is a rule that cannot be bent or broken. It has to be followed for subnetting. IP addresses, it's okay, but subnets, it is not. They must be 1s and then zeros. No intermixing of 1, 0, 1. Cannot happen. No, no, no. So, because of this rule, you can only have certain numbers in a subnet mask because of that breakdown. And here they are, 255, 254, 252, 248, 240, 224, 192, 128, 0, sold! And there they are. So, way back ago, like 17 minutes ago, the subnet mask defines what is a network and host. The network is defined or masked with 1s in the subnet. Anything left over are the host bits. So if we look back at our example, and now we compare it to our subnet, all those 1s are the network ID, which happens to be 192.168.1. The last remaining section are all zeros. Well, the only thing I can put in those zeros are 1 or 0. That's a possibility of 2. There's 8 of them. 2 to the 8th power is going to give me 256 hosts. And if you remember, I said you have to subtract 2. Why? Because you cannot use that network ID and the broadcast ID or IP. You cannot use them. They're not assignable. So it leaves you with 254 hosts. If you remember, the Class B was 65,536. Well, it's actually 34 because you cannot use those other 2. And last but not least, that slash notation. What's that all about? That cider or slash notation is counting the network bits. A slash 24. Well, how did it come up with this 255, 255, 255.0? Count the ones up. There are 4 octets. 3 times 8 is 24. Notice that 3 octets are all populated with 1s. So that slash 30, that slash 29, slash 28, or a slash 16 is just counting the number of 1s in subnet. It's just a shorthand notation. It's a lot easier than writing out 255, 255, 255.0. Red slash 24, now you know what that means. So, hope you enjoyed watching it. Hope you're not ready to blow your brains out. Please do not operate any heavy machinery or try to go dancing or jogging after this. Sit down, relax, have a drink, go to sleep, and you'll definitely be able to pick up the opposite sex at the bar now. Don't try this at all, please. Don't do that.